Good morning everyone, this is Devashish. Today we will learn about a chapter of mechanics, principle of lifting machine. A chapter of mechanics, principle of lifting machine. So in this chapter, first we will start from machine. So students, as we know, we can see in our surrounding various type of machine. What machines help us? It makes our work easier. It makes our work easier. So in this chapter, machine is divided into three types. Machine is divided into three types. First one, simple machine. Second one, compound machine. And third one, lifting machine. Third one, lifting machine. Lifting machine is a part of simple machine. Lifting machine is a part of simple machine. So first we will see what is simple machine. First we will see what is simple machine. Simple machine is nothing but a type of device which help us to do the work. Simple machine is a type of device which helps us to do the work easier. If we will say one example of simple machine, let us say one bed shape. Bed shape is nothing but a shape which has angle. This is a bed shape. It has angles. Suppose somebody has to move the block from here to here, then he can use this slope. To bring the block from above to down. So it helps us to make the work easier. So it is an example of simple machine. Then let's move on to compound machine. So compound machine, as we know, compound means more than one. So it is a combination of more than one simple machine. Means simple machines are assembled to give the frame of compound machine. It helps us to do the work at a faster rate, and more efficient as than manpower. Example for compound machine, which we normally see in our surrounding, like example which we see in normal surrounding like car, bike. These are the example of compound machine. Fan, we can say these are the example of compound machine. Then lifting machine. Lifting machine is nothing but it is a device which is used to lift a weight W, a plank, a small effort P. So using the effort P, when we lift a weight W, it is known as lifting machine. Okay? So now let's move on to one important terms which will utilize in this chapter, that is mechanical advantage. Mechanical advantage, it is nothing but it is the ratio of weight lifted, whose symbol is W, lifted to effort whose symbol is P, applied. The ratio of weight lifted to the effort applied. So mathematically, if we write M dot A is equal to weight means W by P. Okay. Now let's move on to one term, input on a machine. let's move on to one term, input on a machine. What is input on a machine? So normally we know what work done on the system, work done on the system is known as input on the system. So in lifting machine, in case lifting machine, it is product of effort applied and distance traveled by the effort. Okay. Distance traveled by the effort. Now we will move another term, that is output from the machine. Output, the result we will get from the machine, which is nothing but work done by the machine. In case lifting machine, it is as like input device, it is the product of weight lifted and distance traveled by the weight. Okay. Now another term, efficiency of the machine. Efficiency of the machine. Efficiency is nothing but, students, it is the ratio of output of a machine to input of the machine. If we symbolize it in mathematical, then the symbol is nu. This is called nu, which is nothing but output by input. Okay. Now let's move on to another term which will be used in this chapter, that is velocity ratio. Student, we write it in a short form as V dot R. What is velocity ratio? It is the ratio of distance traveled by the effort to distance traveled by the load. So students, the distance traveled by the effort is symbolized as y, and distance traveled by the load is symbolized as x. So if we want to write it in mathematical, so we can write it V dot R as y by x, where y is my distance traveled by the effort and x is the distance traveled by the load. This is the very important terms for this subject. Okay. Now one term they may ask in some objectives, ideal or perfect machine. So what is ideal or perfect machine? The machine whose output is equal to input. Is known as ideal or perfect machine. Now see students, if output is equal to input, the efficiency will be what? 100%. So there is no real machine in this world which is ideal or perfect machine. They will ask in objective what is ideal or perfect machine, then you should write whose output is equal to which conclude as efficiency as 100% is known as perfect or ideal machine. Now, there is a proof that relation between the three terms which learn, that is mechanical advantage and velocity ratio and the nu, that is the efficiency. So how will you do it? How we will do it? As you know, nu is equal to efficiency output by input. Okay? Here before we learn that output of a machine is nothing but, for a lifting machine, distance travelled by the load, that is W, into distance travelled by the load, W into X. And input of a machine is known as, what we are giving input, that is effort, multiplied by the distance travelled by the effort. So if we put this value, put these two value in this equation, you see that is W into X by P into Y. W into X by P into Y. So now see, W into X by P into Y. If I do some mathematical termination to this, you see W by P is equal to Y by X. You know W by P is nothing but mechanical advantage and Y by X is nothing but velocity ratio. So now, as a conclusion, we get efficiency is the ratio of mechanical advantage into velocity ratio. This is the relation between mechanical advantage and velocity ratio. Next class, we will do a problem regarding this and we will move on to the next chapter. So, thank you.